Okay, so now what we're going to be doing is looking at putting all of these different quadratic skills together. What we're actually going to see is all of these different things that we've been finding. What do they represent when you sketch your quadratic? So first of all, we have a quadratic in the question, and it says that we need to sketch it, giving the coordinates of the intercepts of the x and y axes, and also the coordinates of the turning point as well. So first of all, when we have actually been solving our quadratics, those two numbers that we've been finding have actually been the roots of the quadratic. And in simple terms, what that means is it's where your quadratic crosses the x-axis, which is your horizontal axis. So let's start by finding that then. Let's first of all solve this quadratic that we've got here. So we're going to set our y-coordinate equal to 0. Because of course, if you're on the x-axis, your y-coordinate is 0. You're not above the x-axis, you're not below it, you are on the x-axis. So y-coordinate's always 0. We can try and factorise this, and we spot quite quickly that it does factorise nicely. We're just going to get a positive 4 and a positive 2, which means that our two solutions come from the bracket. So how do we make the first bracket be 0? Well, x is going to have to be a minus 4. Second solution though, we need to make the second bracket become 0. And we get a minus 2 for that one. So then, what we can do is put that on the x-axis. So let's say that minus 2 is here, and minus 4 all the way over here. So that's really good. We've already got a couple marks for finding the x-intercepts, or the roots as they're known. To get the intercept with the y-axis, it's a little bit easier. Similar to how you find your x-intercepts, we said to make y equal to 0. Same idea if you want to do the inverse. If you want to find where something crosses your y-axis, you just let your x-coordinates become 0. So let's do that in our equation then, in the original equation. So if I let my x-coordinate become 0, I'm going to get 0 squared plus 6 lots of 0 plus 8. Same idea as before. If you're struggling to think about why it is that you make your x-coordinate become 0, just pick any coordinate on the y-axis and you will see that the x-coordinate is always 0. And when we simplify this down, we get that y is just equal to 8. So therefore, our quadratic must cross the y-axis at 8. So let's say that that's around about there. And then the final part that the question's asking us to find is the turning point of the quadratic. Now that actually comes from completing the square. I'll show you what I mean now. So let's actually complete the square on this quadratic. So first of all, to write it out again. And remember, with completing the square, we're going to halve the coefficient of x. So that's going to give me a positive 3. Then I take away that 3 squared, and I've got the positive 8 still there. Final step, just simplify the minus 9 with the positive 8, which will give us a minus 1. Now from here, we actually have the turning point of the quadratic. All that we need to look at is the positive 3 that we've got here and the negative 1. One way to think about this is how can you make that equation be as small as possible to give us that turning point, the lowest point on the quadratic? Well, actually, when you think it through logically, all that you need to do is make the bracket become 0, and it will give you a value of minus 1, because we've got that minus 1 on the end. So how do you make that bracket become 0? Well, similar to before with our solving by factorization, all that we need to do is let the x value be a minus 3, because minus 3 plus 3 is 0, so of course that is how we make the bracket become 0. So our turning point is going to be a coordinate, the x coordinate is going to be a minus 3, and like I said, that's just going to leave us with y equals, the whole bracket's become 0, we've just got that minus 1 left on the end. And we can plot that roughly on here as well, so minus 3 minus 1, let's say that that's about there. So now what we've got is our turning point. We've also got our y-intercept, and we've also got our x-intercept, or our roots as well. So all that's left to do is to actually put it all together and sketch our quadratic. And hopefully you know that quadratics always have a smiley face shape like this, a sort of U shape. Sometimes they will be reflected and flipped over, but we're going to come on to that a little bit later in the lesson. Your quadratics for now are always going to have that shape there.